Hi everyone, welcome back to our session 9. In this series, we are covering the MLOps basics, and in the current session, we are going to discuss about one of the very important things, how we package the model. And for that, we are checking Docker today. In the last session, we discussed about model packaging using Onyx, which is kind of give you extensibility of running different machine learning models in different frameworks and kind of extending the places where machine learning models could be used. And the second thing is like model packaging or Docker. Model packaging we already understand from our last session. If you do not understand that thing, please go back to the last session that we have. In the current session for Docker, I'll give you an example. What happens is I built an application or service. It was running perfectly fine. I showed the video demo to the other person. Now the chance was to test it out for the other person. I didn't put that thing on server. So I gave those particular files I pushed on Git that particular person downloaded and install everything as what was mentioned in the instructions. However, the same thing didn't run on his machine. I said this thing runs for me. And then what I did is went to the server and did the same thing, and the service or the product that I made didn't successfully run on those machines. Then I realized, oh, there was something, and there was so many errors, like so many things I have to figure out and standardize. Then I realized, and I came to this Docker, in which what happens is you make an application on your machine, you Dockerize, you containerize, you package that particular application in layman terms, and then upload it somewhere, maybe on some machine, on some other person's machine, on a server or any containerization platform. And then you just install those things, run that thing, and that things are going to run fine. So it's kind of standardizing whatever you have on your own laptop systems. However, when you go to different systems, you do not run into dependency issues or OS related issues. So in this particular session, we'll be going through just four things. The FastAPI wrapper, basics of Docker, building Docker container, and a Docker compose. So I hope if you guys do not know about FastAPI, it's one of the best things you can learn for the Python API backend. And I'll be just moving on, understanding that you already know what FastAPI is. If you do not know, just go back and learn and see through what FastAPI is. So we are installing FastAPI UV and then making an app from FastAPI. In that we are making a GET request in which we are saying like this is an sample and project, and then hosting hosting that particular app on your local host. It's just five. You can see it's just 5 to 6 lines, and you have hosted an API of yours on a localhost 8000 port. So now earlier what we were doing, like we were using the Onyx inference. So we are doing the same. From inference or next, we are going to call a model that we have made earlier, call a Onyx predictor, and then we load that particular model and we hosted that thing on this particular app. So do you realize how easy what was it to productionize this thing? Not productionize this thing, but hosting the service that we have built. The problem that occurs here is when you run this thing on your system, it might work, but when you change systems, when you go on servers, when you go on different machines, there might be a lot of dependency issues that might come into play. And to decrease those kind of issues and so to maybe standardize the process, we use Docker. What exactly is Docker? Docker is a container management tool which packages the application code, configuration, and the dependence into a portable image that can be shared or run on any platform. So there are basically three main things in Docker. First is Dockerfile. Dockerfile is list of commands which are required to run for application to run. These are like dependencies, codes, commands to run, etc. Second thing is we have a Docker image. Docker image is a lightweight standalone executable package. It's an executable package of software that is built using by running the Docker file, and that includes everything that we need to run the application, be it code, runtime, system tools, libraries, and settings. And then once we run the Docker image, it's like a Docker when it's like a when we run that Docker image, the instance of that Docker image is contained by something called as container. So for example, a container is an instance of Docker image which contains the running application. So now we'll see like if you're not clear about what I just said, try to understand everything with the form of this flowchart that we have from Dockerfile. When we build it, we get Docker image. When we run the Docker image, we get the we get the image inside the containers, instantiating the image in a container. So for Dockerfile, it's very easy. So from here we are, so I'll just explain you line by line. From here we are getting the transformers library, the latest version of that. Then we are copying the everything that we have in our current directory into the app file that we have. Then we are seeing the working directory is the app file. Then we are saying like please install the requirements, inference requirements.txt, and then expose everything on the 8000 port. Now in this finally we are seeing like a go to command line and run this particular this command is used for the fast hosting FastAPI on 8000 port. So for example, if you see here we run the same thing and here it mentions the same thing. So now let's build a Docker image using the Docker file that we have. So here we are seeing like a Docker build and in this we are taking this particular we are seeing like Docker build this particular inference latest, and then once the image is built, then we are checking like what all Docker images are there. Then we see like we have a repository by the name inference whose tag is latest and the image ID is this. So now we are seeing like on 8000 port run this particular inference container, and then you do not have to do anything. Everything is done by this particular line only. So there are three lines. You make the file, you run the image, you make an image from image uh, just you do build, you do run. That's it. So for example, from the flowchart that we have, so you create a Docker file, then you do build, then you create a Docker image, then it will create a Docker image. You run the Docker image, you'll get the container. That's it. And then one of the things is like this is what we have seen for we can create images or containers for some particular service. But what if there are a lot of service, lot of components of apps that we want to tag along in a that can be that uses different things and we want to tag everything together, or maybe say if you want something for multi-container Docker applications, we use Docker Compose. And basically, Docker Compose is a tool for defining and running the multi-container Docker applications. And with Compose, we basically use a YAML file to configure our application services. Then with a single command, we create and start all the services from for our configuration. For example, this is like Compose YAML. This is a very simple version. This is a very simple way in which we specify the version, the services that we are using in that prediction API, build container name, ports. That's it. And then Docker Compose up. That's it. And you'll get its container will be up and running. You just go to this link or the 8000 port, and we will be able to see the application that we have built. And finally, one of the things is why we are using Docker is to containerize the thing so that we can share and extend those things to different people we have in our team or with the org that we have. Anyone who wants to run that thing, spin up that thing on a server. So, for example, how do we share that thing? There are two ways to share Docker. So, what we can do is we can commit a Docker file which can be used to build the image and container. Or maybe we can push the Docker image that we have to a repository on Docker Hub, and the other person you can pull it on a different system just from the Docker Hub. So I think that's what it was required. For example, I'll explain this flowchart. For example, what happened is we had some Docker file from that I did Docker build and I built an image. Now I pushed that image to Docker Hub that we have or in a Docker registry, and then from Docker registry I just pulled that image to a remote Jetson or remote IoT device that I have, and then on that particular device if I do Docker run, then inside a Docker container my application will be running and I can host like similar to what I've learned just in example. So I hope that was clear to you how we are packaging the model and the whole files using a Docker container. Thank you everyone for this session. In case of any feedback or doubts, please let me know in comments and see you in the next session. Thank you.